An exciting or fascinating world of chemistry. We're looking at acid-base chemistry. Acid-base chemistry, reactions of an acid with a base to form a neutralization reaction, resulting in water and a salt as a product. So let's look at a basic reaction, acid-base reaction, hydrochloric acid with sodium hydroxide. HCl, hydroic acid, that's binary, it's HCl, sodium, Na, hydroxide, OH, NaOH. It's a single replacement reaction. So we get in the reaction, it's direct NaCl because the cation for the base goes with the chloride, anion for the acid, and the other product is H2O. HCl is my acid, NaOH is my base, NaCl is my salt. A salt is defined as an ionic substance that is not an acid or a base. Now, we have two ways of looking at the first science of an acid-base definition. The first was derived by a scientist, a Swedish scientist named Arrhenius. He identified an acid as a substance that produces hydrogen ion when it dissociates, a base that produces hydrogen ion when it dissociates. Okay, dissociation, the process of solution breaking down into its base ions. So let's look at these four processes in terms of a dissociation. So if I take HCl, it's going to break apart into H plus and Cl minus. When it dissolves, it breaks down into its ions, and that's the process. For H2SO4, we get 2H plus because we have 2 over here to bounce on that, and SO4, the polyatomic, minus 2 or 2 minus. We'll do the other 2 in class. All right, so there is a problem with the Arrhenius definition. Sodium bicarbonate and ammonia are both basic, but if we look at the formulas, bicarbonate is HNO3 minus, and NH3, ammonia, they're both basics. There's no hydroxide. So two different scientists, a German named Bronsted and an Englishman named Lowry, came up with a solution at the same time, so we give them both credit. And yes, you do have to put the little line to the zero, then the O, since it's a German name. According to them, an acid base, acid, a substance that donates a proton, a base, a substance that accepts a proton. What are we talking about here? Now remember, we said an acid produces hydrogen ion. Well, what is a hydrogen ion? Well, a hydrogen ion is a proton without its electron on the outside. So basically we have hydrogen ion is a proton. So having hydrogen ion, having a proton, that's an acid, base accepts that. All right, so let's look at the reaction. All right, so if we take Hi plus CuiO2 twice, reaction is going to give us Cui2 plus H2O, and balancing it up, we got acid, base, and salt. Balancing it up, we put a 2 in front of the Hi and 2 in front of the water. We'll do the other one in class. All right, so in terms of weak acids and base reactions, remember we said those go to equilibrium. We talked about acid nomenclature. Quick review, remember acids, we said that binaries are strong. For 8s and 9s, you take the number of oxygens minus the hydrogens. If that number is greater than or equal to 2, it's strong. Less than 2, it's weak. How about bases? Well, we'll make a generalization right now. It's not always the case, but we'll make a generalization. If it has hydroxide in it as a base, we're going to call it strong. If it doesn't have hydroxide, it's weak. Now, what is this thing called conjugate acids and conjugate bases? Conjugate acid is an acid, it acts as the acid in the reverse reaction. If we have equilibrium, what acts as the acid? Okay, conjugate base then acts as the base in the reverse reaction. So let's look at a reaction here. NaOH, sodium hydroxide, plus HC2H3O2 acetic acid. Now, NaOH is my base, and it's strong because it has hydroxide. HC2H3O2 starts with an H, therefore that's my acid. Count the number of oxygens, I have 2, minus the number of hydrogens, that's 3, that's minus 2, that's definitely less than 2, so it's weak. If one or both of the acid or base are weak, we have an equilibrium reaction. All right, so that means our reaction here. Na is going to go with C2H3O2, and we get NaC2H3O2. H is going to go with OH. We have H2O. NaC2H3O2 is my salt. Now, conjugate acid, we got a reverse reaction. Which one acts as the acid? Which one starts with H? Well, H2O starts with H, so H2O is my conjugate acid, and 99.99% of the time, water is going to be a conjugate acid, and the salt, 99.999% of the time, is going to be a conjugate base. All right, so we'll do these two in class, all right, and we'll do these two as practice as well. Any questions, let me know. With that, we are done. Take care.